All right, problem number 3 on this is, where to go here? A little slope field, sorry, I have the slope field up here. The first question, so we got a derivative is 2y minus 4x. They give me the slope field. They asked me to sketch the solutions through 0, 1, and 0, negative 1. So I just kind of take the slopes and draw those. So I think that's the one that goes through 0, 1. That's the one that goes through the point 0, negative 1. Kind of just graph those tangents. Part B says find the value, Euler's method. Again, so you can see Euler's method is showing up a lot. I think it's going to show up one more time this week. So Euler's method, they told us that f of 0 is 1. They want to find f of 0.2. I'm going to go through this a little faster since we've done this one before. So we're going to start with the 0.01, take that 1, add the step size. We're going from 0 to 0.2. So 2 steps, so my step size is 0.1. Typically Euler's method is 2 steps. So we got to plug in this 0, 1 into this. X is 0, y is 1. I get 2, so I get 1.2. So it moves 1.1, so now I'm at 0.1, 1.2. I'm going to do the same thing. I'm going to take that 1.2, to that the step size, which is 0.1. I'm going to take this value right here and plug it into that. 2 times 1.2 minus 4 times 0.1 to give me a 2. I'm up, get 1.4. Part C says if y equals 2x plus c is a solution, find b. So if this is a solution to that equation, or to this equation here, it means when I plug it in, it needs to work, right? So I got dy dx equals 2y minus 4x. I'm just going to plug this in. So dy dx is the derivative of this, which is just 2. 2 times y, which is the 2x plus b, minus the 4x. They set this up in such a way for this to happen, because otherwise normally you'd have these x's floating around, but the x's cancel out. You get 2b equals 2. I think I made a little mistake there, right? And b equals 1. 2b equals 2, so b equals 1. And the last part of this question is a tricky one. First question says, if the function has this derivative, does the function have an extreme point at 0, 0? And then if it does, is it a minimum or a maximum or neither? So my first thing was I took the point 0, 0 and I plugged it into the derivative. Pretty easy, 0 minus 0 is 0, so I got 0. So since the derivative is 0, by definition, it's a critical point or an extreme point. So now the question is it a minimum or maximum or neither? So this is a perfect example. The one type of example is when we might need the second derivative test. A lot of people forget the second derivative test because normally we would do the first derivative test. You take your 0, x is 0, you put it on the number line, you put a number to the left, number to the right. The problem is we've got to put this back into the derivative, but the derivative includes y. So if I pick an x value like -1, sure, fine, -1, but I don't have a y value that goes along with that, right? So I can't use that first derivative test. So we have this other test called the second derivative test. The second derivative, you might remember, probably not, it's been a long time. The second derivative test, if you take the second derivative and just plug that critical point in, remember the second derivative tells you concavity, right? So if you put in the critical point, the 0, 0, and you wind up getting concave up, that means that critical point had to be a minimum point. And if you got 0, 0 and you plug in, you got a negative, that means it's concave down, so it would have to be a maximum point. So the second derivative means take the second derivative. So here's the first derivative. So the second derivative is 2 times y prime minus 4. And remember, y prime is just that. So 2y minus 4x goes in for y prime. So now I got the second derivative. I'm going to take my critical point 0, 0, plug it into the second derivative. So this is a big fat 0. And I wind up getting -4, which means the graph is concave down, which means I have to have a maximum point. Remember when we did the second derivative test in class? Why don't we do the second derivative test? It's a waste of time. Yep, most of the time it is. We don't deal with it. But this is one example. I think we're going to see another problem next week, and a problem I do with a series of problems where you have to use that second derivative test to find a minimum or maximum point also.